More than 2 years have passed since that clear autumn day, but the memory of the Soyuz MS-23's return remains a prime example of mission success. On September 27, 2023, a small capsule descended from the heavens under a massive parachute, carrying its precious human cargo back to Earth. This was landing day for the crew of Expedition 69, marking the end of their extended stay aboard the International Space Station. For those of us watching from mission control centers and from living rooms around the globe, it was a moment of collective focus and quiet anticipation. The landing took place in the vast, open steppes of Kazakhstan, executed with the precision of the storied Soyuz program. The mission itself was notable for its duration and the circumstances surrounding it. Sergei Prokopyev, Dmitry Petelin, Frank Rubio spent a remarkable 371 days in orbit. Their extended stay was caused by a coolant leak on their original ride home, the Soyuz MS-22. The MS-23 capsule launched uncrewed as a replacement. The crew adapted to the longer mission, continuing scientific research, handling station maintenance, and contributing to our understanding of long-duration effects on the body and mind. The return journey was the culmination of over a year of work in microgravity. Each member played a critical role aboard the ISS. Prokopyev served as commander. Petelin served as a flight engineer. Rubio served as a flight engineer. They contributed to hundreds of experiments during Expedition 69. Biology, human physiology materials, science, Earth observation. The end of the mission was about returning data and the human experience after living and working 250 miles above Earth. As the world watched the live feed, the focus was entirely on the final 5 minutes of descent. Engineering and physics choreographed the sequence to slow orbital velocity to a gentle touchdown. Every signal, every deployment, every burn. The mood in control rooms was calm professionalism, reflecting countless hours of training and simulation. This was the final test of a system honed over decades. The successful return was a shared victory for international cooperation. The day's events began long before the capsule entered Earth's atmosphere. The process started with heartfelt farewells aboard the International Space Station. The departing crew shared hugs and final words with the colleagues they were leaving behind in orbit. After the final goodbyes, the hatch between the station and the Soyuz MS-23 was sealed, signifying the official start of their journey. Hours of meticulous system checks followed, verifying every switch, verifying every valve, verifying every computer was ready. Ground controllers in Russia verified telemetry. Ground controllers in the United States verified telemetry. The command was finally given. The hooks holding the capsule to the station disengaged. The latches released with a gentle push. Undocking occurred flawlessly, high above the Earth. The Soyuz capsule slowly and deliberately backed away from the massive orbiting laboratory. Onboard cameras captured the iconic view. Station cameras captured the small spacecraft drifting into blackness. The brilliant blue and white curve of the Earth served as a breathtaking backdrop. For a time, the Soyuz flew in formation with the station. Then it performed a separation burn to increase distance. The crew was now truly on their own, committed to their return trajectory. The most critical maneuver of the pre-entry phase was the deorbit burn, a precisely timed 4.5-minute firing of the main engine. It acted like a brake, slowing the spacecraft for Earth's gravity to capture it. The burn had to be perfect in timing, duration, and direction. As the engine ignited, the crew was pushed back into their seats. The first feeling of significant acceleration after over a year in weightlessness. During this time, communication with the ground is temporarily lost during a period known as the communications blackout, caused by the ionized plasma blocking radio signals. For these few minutes, the crew and the capsule are on their own, relying solely on their training and the spacecraft's automated systems. Emerging from the blackout and the most intense phase of heating, the capsule continues its rapid descent through the denser layers of the atmosphere. The next critical event is the deployment of the parachutes, a multi-stage process that begins at an altitude of about 6.5 miles. First, 2 small pilot chutes are deployed. Their purpose is to pull out the much larger drogue chute, which is designed to stabilize and dramatically slow the capsule from supersonic speeds. The crew feels a significant jolt as the drogue opens, a welcome sign that the system is working. This phase is crucial for positioning the capsule correctly for the main parachute deployment, ensuring it is descending at the right speed and orientation for a safe final approach. The climax of the atmospheric descent is the unfurling of the enormous main parachute. At an altitude of about 4.5 miles, the drogue chute is released. The single, iconic white and orange parachute blossoms open, catching the air and slowing the capsule to a relatively gentle descent speed of about 16 miles per hour. We see the main canopy. A calm voice from the Russian Mission Control Center announced, a statement met with relief and applause. For the crew inside, the view out of their small portholes would have changed from a fiery blur to the serene landscape of the Kazakh steppe coming into focus below them. The most violent part of their journey was over, and a soft landing was now just minutes away. The final moments before touchdown are a unique feature of the Soyuz landing system. While the main parachute does the heavy lifting of slowing the descent, the capsule's final landing speed would still be too fast for comfort. To cushion the impact, 6 small, solid-propellant soft landing rockets are embedded in the capsule base. Seconds before ground contact, a gamma-ray altimeter triggers them to fire. The rockets give a final upward thrust, bringing the capsule to a near stop, a gentle drop. The crew felt a firm but manageable jolt as the capsule hit the Kazakh steppe. The moment of touchdown, recovery operations swung into high gear. Rugged all-terrain recovery vehicles race across the steppe. Helicopters that track the descent converge on the site. Highly trained ground crews prepare for any contingency. Their first task is to safe the capsule, checking for pyrotechnic hazards. They establish communications with the crew and confirm status. The crew is feeling well. The site commander reports, relayed to anxious mission managers and families. That confirmation is the true moment of mission success. Extraction is careful and deliberate. After over a year in microgravity, the crew must readapt to Earth's gravity. Their balance is off and muscles weakened. Recovery teams open the hatch and help each crew member out. Crew members are carried to reclining recovery chairs beside the capsule, draped in warm blankets, sheltered from the sun, given water, and given a chance to make first calls home via satellite phone. Smiles, waves, a palpable sense of relief as they breathe fresh air after 371 days. Medical checks begin on-site immediately. Flight surgeons run initial health assessments and check vitals for high G and gravity return issues. This begins their long road to full recovery. The crew is flown by helicopter to Karaganda for a welcome and fuller medical exams. Roscosmos cosmonauts head back to Star City, near Moscow. The NASA astronaut boards a plane bound for Houston under constant medical supervision. The safe landing of Soyuz MS-23 on that September day in 2023 was more than just the end of a single mission. It was a reaffirmation of the reliability and robustness of a spaceflight system that has been the workhorse of human space travel for over half a century. Each successful touchdown adds to a legacy of engineering precision and operational excellence. It demonstrates that even when faced with unexpected challenges, such as the coolant leak that extended this particular crew's stay, the international partnership has the plans and the hardware in place to ensure crew safety above all else. This builds confidence not only within the space agencies, but also for the public, reinforcing the idea that human space exploration, while inherently risky, is a manageable endeavor. The return of Prokopiev, Petelin, Rubio. The 3 crew members sitting in chairs after landing, smiling and giving a thumbs up to the camera. As Frank Rubio set a new U.S. record for the longest single spaceflight, he and his crewmates became invaluable subjects for research into the long-term effects of space on the human body. Scientists on the ground were eager to collect data and samples immediately upon their return, studying everything from bone density, lost muscle atrophy, cardiovascular changes, vestibular system changes. The knowledge gained from their year-long journey helps pave the way for future, more ambitious missions, including multi-year expeditions to Mars. Reflecting on the mission, officials praised the crew's resilience and professionalism. They've shown a great deal of fortitude and a great attitude through a mission that was extended beyond what they thought it was going to be. These sentiments were echoed by their Russian counterparts, highlighting the strength of the collaboration that keeps the International Space Station running. The mission served as a powerful reminder that in the quiet, focused environment of space teamwork and a shared goal can overcome challenges and strengthen bonds, providing a model for cooperation back on Earth. In conclusion, the story of Soyuz MS-23's epic recap is one of triumph over adversity. It began with an unexpected extension and ended with a perfect return to Earth. The landing was a flawless execution of a complex series of events, from the fiery re-entry to the soft touchdown on the Kazakh steppe. It showcased the incredible skill of the crew, the dedication of the ground teams, and the enduring reliability of the Soyuz spacecraft. More than 2 years later, the mission stands as a significant milestone, a testament to human ingenuity and the unyielding spirit of exploration that continues to push us toward the stars, always with a steady hand guiding us safely home.